Hello everyone. This film series will help you understand some of IntelliTwin's capabilities by demonstrating particular use cases. These cases, broken up into several instructional films, will show scenarios that a user of IntelliTwin may encounter. Okay, let's have a look now. In this video, we'll see how a typical CFD workflow is accomplished with IntelliTwin. We'll also introduce the key concepts of IntelliTwin: the IntelliTwin server, metadata database, session manager, and the sandbox. To use IntelliTwin, the engineer logs into the IntelliTwin server through a browser. The IntelliTwin user interface is a zero-footprint web client requiring no software installation. The IntelliTwin server can be provisioned to any on-premises system or off-premises cloud. All metadata from all users is recorded and maintained in that metadata database. This user has chosen to work on his vWing Suite project. Within that project, a workflow will be selected. We'll get into workflow control details in a later video. An important point is that the choice of HPC system and submission queues is selectable at workflow start. Once the selection is made, the IntelliTwin server starts the session manager for this user on the chosen HPC. If a secure login by the user is required, IntelliTwin presents the appropriate authentication dialog before proceeding. Based on the rules contained in the workflow definition, a file directory structure called the sandbox is created on the HPC system. This is where all the file artifacts used and created by the workflow processes will reside. All through the workflow execution, the session manager records metadata about the files used and created. The codes that are used, the processes themselves, and the workflow itself. Unlike most SPDM systems, IntelliTwin records the provenance of the processes used as well as the files. This workflow has been defined to require a mandatory configuration geometry exported from a PLM system. As the engineer exports the configuration, the PLM system's API will be used to invoke a small Python module that uses the IntelliTwin API to record the metadata about the configuration at export time. This way, a solid chain of custody is established. The exported configuration is moved by IntelliTwin to and from the local user system to the sandbox. Various mechanisms are available in IntelliTwin to do the copy. It's all up to the customer to decide. The engineer does not have to be aware of the file path to the sandbox or subdirectories within it. This is all handled by the sandbox and IntelliTwin. IntelliTwin then recognizes that a mandatory file has been placed in the sandbox and can proceed with the workflow by starting an HPC job. IntelliTwin can start and manage thousands of users' jobs. As we'll see in a later video, the job status in the queue is monitored and recorded as persistent metadata and can be checked at any time by the engineer from the initial login or any subsequent login, even from an authenticated mobile device. As Code 1 completes, Code 2 is initiated by IntelliTwin. Each step of a workflow is called a stage in IntelliTwin. This workflow has 3 defined stages. Stage 1 loads the PLM data. Stage 2 runs code number 1. Stage 3 runs code number 2. This example is simplified to show just 3 files in the sandbox. As you probably know, the situation is usually far more complex, involving many files. This is where one of IntelliTwin's main advantages shines. All of the file and parameter artifacts are organized and accessible in the context of the engineer's workflows. The user selects his vWing project, and within that, the new Kestrel vWing sweep angle of attack workflow. All aspects of the workflow can be browsed, including the HPC job history, file artifact metadata, as well as metadata about the workflow itself. There's ample room to store user-defined keywords and project specifics in this metadata. The metadata also identifies the physical sandbox location as well as the workflow template that define this workflow. In a later video, we'll see how files and other artifacts can be accessed for copy, paste, and visualization through the sandbox paradigm. Thank you for watching.